Welcome back. Let's continue with arrays. And I'll do that by going through, let's see, we had the class fizzbuzzer, and we've done the call num method, and let's go on with the list and the count methods and see how we can use arrays in them. Let's start in the start method and add the tests for it, because that's what we as good engineers do, right? We write the test cases first. And what we want to do is we want to call the list method with a start and an end, like this, and this should give us back an array of strings. Like that, and then we want to print that. It's, I guess, a good idea. And then we can do that. We can do that in two ways. We can either do a normal for loop, like and I is less than the length of that array. And then we can just print the values in it. Something like this. We can make it nicer if we want to. We can make it look more like an array when we print it. We can start with the start bracket, end with an end bracket, and a new line, and in the middle we just print the values and add a comma. That should look rather nice. There is another way of doing the same thing that doesn't require us to know the length of the array that we are printing, which is, I kind of like it better because it means I don't have to worry about creating a variable in this type of for loop, and that's the for each method, or it's not a method as such, but there's a for each construct in Java, which looks like, if I take this away, comment that away, and then write instead for, and I get a string out of the list, like this. And then basically we print in the same way. Except now we have one variable, which is the s that I created up here, and I can use that. And this will give me the same output, but looks much nicer, and I don't have to worry about how big the array is, or whether sometimes in Java it's length, sometimes it's a method called size, and this is relatively inconsistent, so it's much better if I don't have to worry about that, and with this construct I don't have to worry about it, so I like that. This will take care of the test of the list method, and then the count method, which is more or less the same thing. Start and end, and let's be nice and just say that I want to pass something along to it. I want to pass the output function for it, so that I can count to a file, or I can count to the screen, or something like that. There, that should take care of this. Now we can go on to the fizzbuzzer class and actually implement the list method and the count method. Okay, first the list method. So it returns an array of strings. And I have a start value and I have an end value. And what I want to do here is I could statically create an array which is end minus start length, and then I have to double check that start is smaller than end and so on. Or I can just do a dynamically growing array basically until I have all the values I need, and then I convert that into a static array, which then I can then return. I've already used the array list class, so let's reuse that one. Like that. And then there's a for loop. From start to end, and increase by 1. And then append whatever I get from column. And once I'm done, I just return this as an array. So this method requires me to also give an example of the type of array I want to return it as. So just create an array of size 1 with elements of the type string, and as a template, so that the toArray method knows that okay, it's a string array he wants, and then I'll return this. Go on to the count method, and I'm actually going to write 2 count methods. One which basically is a default one that will default to printing to screen, and the other one will take an argument that says where it should be printing to. So call this other, and this specifier here isn't really necessary, but I can use it if I want to. Alright, and I create a list. Actually, I create an array. In which I call the list method that I just wrote. So I'm calling this method just to get an array of strings, and then I'm going to print this. And I'm going to use the same construct again. And once I'm done, let's print an end bracket as well. There we are. I don't need to return anything, and that should take care of it. I need to include or import the print stream or print stream class that I used as well. Like so, and that should take care of it. So now I have my list method, and I have 2 versions of the count method. One with 2 arguments and one with 3 arguments. And in my start class, it was the one with 3 arguments I was using. I could have used the one with 2 arguments, but yeah, it makes it nicer like this. Or gives the exercise at least. So, let's see, where am I? And let's run it. Okay, so I compile it, and I did the first. Hang on, let's switch to that method or that class. So first is this calling with, which tests that the column method works, and then I print the array, or the result of using the list method, and then I do the count method. Let's be even clearer and say like that. Testing list and testing count. Of course, what we can do now is that we can break this out into 3 different methods, because this one is doing 3 things now, this test fizzbuzz method. So let's refactor a bit. This does that. This one does that. And then the third one. And now we can just call them each in order. Like so. Compile and run, and we get the same output, except that this is much easier to read. One more thing I'd like to do is, quite often when you work with arrays and stuff, you want to have a nice output of the elements in the array. In this case we get strings back, so we don't have to worry, but sometimes you would want to have the array of the actual objects. Let's add a method for that. Let's call it test debug or something. Like so, and then just so we have 20 values there as well, and here we'll do that one then. Or actually, no, this isn't what we want. What we want to do is that we want to just print our list of calls. Convert that into array just so we have something to work with. And then it's like this. So take the list of calls I had in my calls, convert that into a regular array, and say that I want an array of callouts. That's what I want to have. Go back to the start method and fix that. And let's see what we get if we do this. And if we look here at the bottom, what we see is this is what you get when you print an array. That's not exactly what we wanted, right? And that's what we want to fix now. We can't just print an array like this, we have to do something with it. So first of all, let's store it in a variable. Like that. And then we need to run through the array and print each one of them. Like this. If I run this, let's see what I get now. And I still don't get exactly what I want, right? What I get now is I get 3 elements, or in this case I get 2 elements over here. This is the first array, with just fizz and buzz, and here is the 5s, 10s and 12s. What I see now is the pointers. That's not exactly what I wanted either, is it? So let's go into the callout class. And add a method called toString. This is a method that all Java classes have, either implicitly defined as returning the pointer or explicitly defined as return whatever I say that it should be returning. Like that, for example. Now we see that the output of this printing of the array is that I have an object of the type callout, which is basically, well, I decide how I want to print these things, but sure, callout with the value 3 and the callout fizz. With the value 5 I get buzz, and down here I have value 5 is 5s, value 10 is 10s, and value 12 is 12s. So this method, and you noticed here, and when I called these objects, I didn't have to make a conversion or call the toString method or anything like that. That is done by Java internally. Println expects a string, so it'll try to convert my callout object to a string, and it'll do that by calling the toString method, which gives me exactly the output I wanted. So where was I? Here we are. What have we now learned? We have learned that we declare an array, with the type, and then some empty brackets and the name of the variable, like that. This doesn't actually create the array, it just says that we have a variable called myArray, which is of the type string array. If we want to do something with it, we actually have to create it. In this case, I'll be creating an array of 10 elements. And if we go to the start class, you can see down here is another example where I'm creating an array. So I have an array of the type callout with 3 positions, which I create here, and I put that into the variable calls, and then I'll index the different positions starting from 0 like this. And each of these positions need to have, I need to fill it with an object, which I create by new. If I have a growing list of, or a growing array, I'll be using array list. Which I'll then use add on to grow, and I can shrink it of course as well, and then I'll cast this to an array once to a proper array once I'm done. If I have an array of the right type, and I can of course pass that in just as easily. But since if I don't have it, the easiest way is to just create a dummy array with 1 position in it, and then give it to the toArray method as a template to copy from. Other things we've done is that we've looked at method overloading. In the fizz buzzer we have those 2 methods, both of them called count, but with different method signatures. And what else have we learned? We've learned the for each construct. And that's about it. So this for each construct is very nifty for you working around, working over all elements in an array. But there's no way of knowing which element I'm at the moment, which position the element has. I can just do it for every element in the array, do this, and I don't care about what position it has. Probably, I haven't tested it, but probably I could use that directly on an array list or any iteratable object, but the syntax is the same anyway. Okay, and that takes care of arrays for us.